know, I used to call you my smartest geometry class, but first period came in and did their bell ringer, and 8th period has been, they're on my nerves with their behavior. There's this, but otherwise, like, their math has been spot on lately, so, not that y'all haven't, but, oh my gosh, it's like I told you, once May hits, people just get dumber and dumber every day. It's okay. We'll get through this somehow. What's happening tomorrow? There is a quiz. I'm putting that quiz, since I'm giving up my class time. Anytime I give up my class time, I put it in the 60. So it's not worth 100 points, but it is going in the 60% category. That's the bad/good news. The even better news is some people didn't notice that I changed the bell ringer. I wanted to do Thursdays because I felt like I had written all over my Wednesdays yesterday trying to solve. So I assumed you had to and didn't have any space. So that's why I did today with a Thursday. What's happening on Friday? You do get the semester exam study guide. Everything that we've done that's chapter 10 so far is due, and there's a third thing that's not on the list. There's going to be a notebook test on Friday as well. There were some other words that I was supposed to use, but I don't recall what they are. Danny, when we get done with the notes, remind me to post the key to the worksheet. So we got a 10-1, 10-2 worksheet. It's due on Friday. I'm going to post the key. So while me and Nick might both name the circle the same way, because if it has a center of R, then we're both going to name it circle R. Duh, I got that. But there are some problems where Nick's going to actually show some work so I can give him his points, because otherwise I think he's just copying my keys. I'm doing that in lieu of a study guide. I need help with the bell ringers. The sooner I'm going to try. Last period I spent too long on notes, and they didn't have very long to work on their worksheet. I want to fix that this period, so we're going to go a little fast. I need to distribute that 5.3. I know it's 5.3V. I don't know what 5.3 times 5 is. I don't know what 5.3 times 5 is. This. Okay, then I distribute that 3. I would have 3 plus, I don't know what 3 times 3.5 is. Toby's not the only one in the room who knows how to use a calculator. Not just Danny, sorry Danny, Danny too. We can combine the terms on the right hand side. We would have 5.3V minus 26.5 equals 10.5V minus 0.02 plus 0.02 plus 0.02. Katie, for today, while we do the notes, move to that index with the weird shape. Now what? Sounds great. I'm going to write all over Friday's bell ringer because we're doing a notebook check then anyway. So I have 5.3V equals 10.5, don't care, V plus 26.5 plus 0.02. Thank you, Toby, yet again. Next. And I get and you get what? We did too, last period. And that does make sense because 5 times 5 is 25 and 26 is just a little bigger than 25. So that makes sense. It's 5 point something. Just like yesterday, and for some reason all week long, the second bell ringer is much easier than the first. I'll leave that up there for a second longer. On the second bell ringer, we need to combine like terms, so we would have 10W plus 6 equals 7W minus 21. You thought I was flying before. I'm a super fly now. minus 7w, minus 7w. I got 3w plus 6 equals negative 21. You're on my nerves. She got moved there because she was in trouble for talking. Do you really think she's supposed to be talking to you? Okay, yesterday we did circumference, radius, diameter, chord. Today we're doing some more circle vocab. It's different parts of a circle, just as easy. Most of this is straight common sense. I believe I've hole punched again on the wrong side. We're going to start with this side. We're mostly talking about angles and arcs today, although we are going to use radiuses and diameters and the other parts of a circle to help us solve. The first blank is central. A central angle of a circle is an angle whose vertex is at the center and whose sides are two radiuses of a circle. For instance, 1 is a central angle. Vertex at the center, the sides are radiuses. In the tiny circle to the side, there are 3 angles shown. If you add all 3 angles together, all 3 central angles, what number should you get? Yes, all circles have a sum of 360. So that's the magic number we're going for today. The first example is just us trying to find that missing angle. Does someone know the answer to number 1? Tell me again, ma'am. I need the answer to this first circle. It is 140. How would I do it? I would do 360 minus 130. You get 230. 230 minus 90, you end up getting 140. So all I'm doing is subtracting out the 130, subtracting out the 90, and I find that missing angle. Okay, someone different, using that same logic, what is the answer to number 2? It is 50. I do 360 minus 165. I don't know what 360 minus 165 is.
195.
Okay, and then I do 195 minus 145, and I get 50. All we're doing is subtracting the other angles from 360 to find that missing angle. The last one has more pieces, so it's going to take a second longer. What is the answer to the last one?
145.
Is it 140 or 145?
145.
Well, I don't know. Let's find out. So we do 360. I'm going to do the 40 first. That seems easy. 360 minus the 40. That brings us to 320. 320 minus 90. That brings us to 230. 230 minus the 85. That brings us to 145. Are there any questions about that first one? Okay, then on our second one. An arc, can't spell arc today, is a portion of the circle defined by 2 endpoints. A central angle separates the circle into 2 arcs whose measures are related to the measure of the central angle. Okay, so when I think of an arc, I think of the crust, But when we're finding the measure of the arc, that's why it matches the central angle. Okay, so I'm going to go color crazy. There's that one. This one says ADB, so that'd be here to here. I've colored it in. And this one says ADB as well, so I've colored it in. Okay, so if we want to know the measure of this arc, before I even say that, let's talk about it. Okay, of course, with anything good in life, there is a vocab term. The tiny arc, the smaller arc, it's called a minor arc. The big arc, larger arc, is called a major arc. And then the one that's half a circle, as we've already heard before, it's called a semicircle. Now, for those of us who don't understand major, minor, and semicircle, I relate everything because when I think of circles, I think of food. So I'm relating everything to pizza. To me, the arc is kind of like the crust. And when we're finding the measure of the arc, we're really finding how much pizza did Grant eat. If Grant ate this much pizza, he ate less than 4 slices. I'm thinking of a standard 8-slice pizza. By the way, if your pizza's fancy, you're out of my league. So if Grant ate this much pizza, he ate less than 4 slices. If Grant ate this much pizza, he ate greater than 4 slices. If he ate exactly 4 slices, he ate half of the pizza, it's a semicircle. So I relate it to pizza. You could also relate it to Pac-Man. Is it what Pac-Man's eating? Is it the giant Pac-Man? Or I really don't know how to help you with semicircle. It's a semicircle. Yeah. Right before death when you're like crunching down. Okay. If we put a number on that central angle, like a 30, that will give you the number for that minor arc. Whereas that major arc would then be 360 minus 30. It would be 330. Isaac, if you think that wasn't annoying, it was. Besides the annoying noise, something else that super annoys me with circles is when people see a semicircle and they automatically don't put the number 180. That will happen. There will be a quiz tomorrow. One of them will be a semicircle. And because she's not listening and she's playing on her phone, when it's semicircle, she's not going to put 180. That's how it's going to go. Okay, so first we have a circle K. It says that GJ is a diameter. We're supposed to identify major arc, minor arc, semicircle, and find its measure. So the first one says GH. Is GH major, minor, or a semicircle? GH, it's minor. It's less than half. It looks like what Pac-Man's eating. It's less than 4 slices of pizza. It's a minor. What number can I put for the measure? 122. What am I doing up here? What am I doing up here? Yes, but what am I doing up here? But doing what? Who am I teaching? Am I? Okay, the second example says GLH. Is that a major or minor? And what number can I put on it? Why?
Because it's subtracted 60 from 1.
Yes, and you get to 38. Although, if you want to make life complicated, which you can, you could have solved that semicircle. Said that that missing piece, the HJ, was 58. And then 180 plus 58 and gotten 238 as well. I had someone last period do that. I think that's smart. Okay, our next example, along the same line, it asks for MQ Is MQ major, minor, or semicircle? I need a number. Yes, because you do 180 minus 115 to get 65. Why did I do 180? Because there's a semicircle right there. So 180 minus 115 would get you that missing 65-degree piece. Okay, next they ask about MNP. What should you put for MNP? If you're trying to annoy me, you won't put the number 180. And last but not least, they ask for MNQ. MNQ. Now make sure you're going in order, because MNQ, if you just went straight from M to Q, you would have said minor as well. So MNQ is major. I've highlighted most of the circle. I need a number. I couldn't understand that number. Thank you. So the easiest thing to do would be 360 minus the piece I didn't highlight. So I highlighted here, 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 here. I highlighted everything but that 65. So 360 minus 65 is 295. That would be the easiest way to solve it. Are there other ways? Of course. Yes, just like in our example above where you made the noise, the 30 and the 330. Yes. Okay, flip to the back, and we'll get to why this is important. One bad reason we shouldn't have saved, something has to go at the end. I don't know what you can do. You have to keep doing that. But one bad reason that circles are at the end of the year is because of what's on the back of the notes, a pie chart. There is probably going to be a standardized ACT question that involves you interpreting information from a pie chart like this, although theirs will be a little more complicated. So on ours, they're only going to ask us about one piece at a time. For instance, they ask us about CD, which is just volleyball. On the ACT, they would probably ask you volleyball and basketball, or volleyball and softball, two pieces at once. I'm getting ahead of myself. What should I put in that first blank? Yes, thank you. Same vocab word we've used all year. Congruent arcs have the same measure. They are in the same, or they're in congruent circles. Okay, so for CD, they ask for the measure. I see it has 18%, but my answer is not 18. Why is that? That's one good reason. What's another good reason? It's a percentage, it's not an actual measure. That's one good reason. What's another good reason why the answer is not 18? What do circles add up to? What are our numbers going to add up to?
64. Like if you add all this up to
What should they add up to normally, though?
60.
Percentages.
Oh, percentage.
100%. So we already knew they weren't going to add up to 360. Although she's right, for some reason they don't even have everything on. It doesn't even add up to 100, so I don't know. Okay, but how many degrees are in a circle? Okay, so if we want to know 18% of this 360-degree circle, what math should we do? We want to know 18% of this 360-degree circle. What math should we do? If I told you I wanted to multiply something times 360, what should I multiply times 360? Should I do 18? You do 0.18, 0.18. Because 18% is 0.18. So you do 0.18 times 360. What number do you get? So the measure of this arc is actually 64.8 degrees. So we found this one. And then they ask us for BC. Why? They were both 18%, so that number is going to stand. It should also be 64.8. No math required. The next one says EF. That's 14%. So I need to know 0.14 times 360. 50.4. Well, that sounds perfect, because 14 is less than 18, and your number was smaller, so great. And then they asked for FA, but it was also 14%. So my answer is still going to be 50.4. Yay, congruent arcs. Are there any questions about that one? Okay, next vocab term. Something arcs have exactly 1 point in common. I'm going to say, for instance, yeah, like this arc and this arc both have C in common. They're next to each other, so the vocab term is adjacent. A-D-J-A-C-E-N-T. Adjacent arcs have exactly 1 point in common. They ask us to find the measure of the next couple. We don't even have to say major, minor, or semicircle, although that is probably good practice. So AED, less than half the pizza, so it's a minor arc. I need a number. Say it again. Yes. So it's 63, because that piece was 63. Plus 90, because that piece is 90, and you get 153. That's good. And then the next one says CE. We're going to skip it for a second. Let's go. I'm going to skip around. I want to go to D. D says AEC. What should I put for D? Why? Okay. And then the next two require me to solve a little bit more. Does anyone know a number I could put on BC? Why? That like made my whole week. That was good. Vertical angles are congruent, and they are both 63. And no one ever notices that. What's CD then? And then what's AB? Nick. Yeah. So I wouldn't have. Most people don't notice the vertical angles. If you didn't, don't feel bad about it. Most people wouldn't have. What I would have done is I would have solved that semicircle and said 180 minus 63 is 117. Then I would have solved that other semicircle. Again, 180 minus 117, you get 63. And last but not least, there's a third semicircle in this picture. I know this one's 90. The far one, I know it's 90. So I know these two have to add to 90. 63 plus 27 is 90. Okay, we can finally answer the two missing blanks then. We need to know CE. So we do 27 plus 90 and we get 117. We also need to know ADB. Okay, so Eric is over here making life complicated. He's doing 63 plus 90 plus 27 plus 63 to get the answer. Will he get the correct answer? Yes. Is he making it complicated? Yes, he is. There's a better way. What's the better way? 360 minus that minor arc will give you that major arc. So we want everything except this. We want everything. We wanted everything. Here, here, here. We wanted everything except the white. So why not subtract the white out? 360 minus the white will give you the colored. So 243. Would Eric's way work? Yes, it would. Is he making life complicated? Yes, he is. Now we have a formula for the arc length, and it looks really similar to me to another formula we've seen in the past. Don't worry, the formula will be on the board. It really does. What did the X stand for in our other formula? It is still going to be the central angle degrees. But today, we're not trying to find a piece of the sector. We're just trying to find the crust, and we call the crust the arc length. We're going to get tiny numbers, because if you were to really take a pizza and measure the crust, it would be a tiny number. Can you get large numbers? Yes. If you had a really large pizza, you could get a really big number for the crust. We're not going to do that one. We're only going to do two of them. So the first one, L equals X over 360 times 2 pi R. I need to know a number to plug in for the angle. 75 over 360 and then times 2 pi R. What is my radius? Okay, type it in your calculator. Give me a decimal to 2 decimal places. 5.1? That is correct. Thank you, ma'am. 5.24 inches. The second one would be the exact same way. In fact, it's annoying because it would still be 75, but instead of a 4, it would be a 6. Let's go to the last one. I need a number to plug in for the degrees. Say it again. 130. That's a 3. It's 130. It's tiny though, I'll give you that. So they want ZY. It is 130. You could potentially have to solve the circle. This one you do have to do a little more work. What number do I plug in for R? 5, because they gave you the diameter and you need the radius, so it's half. That's the only way they could trick you besides making you actually solve for the angle. What answers should I get? That is 11.34 centimeters. You have your 10-1 and 10-2 worksheet. While they're technically not due till Friday, Lord knows it's best to practice this before you take a quiz on it. Don't be that genius. Go ahead and get it over with. You've got some time if you're trying